back again to a new lecture of the chapter number 7, that is lecture number 13. And in this lecture we will solve two questions from the exercise 7.2, question number 5 and question number 6. So let's start with the question number 5. In question number 5 it is given that ABC and DBC are two isosceles triangles. Okay, ABC and DBC are two isosceles triangles on the same base. It means we have to draw two triangles having base equal. Okay, for example, suppose this is a base BC. Now we have to draw two isosceles triangle. Suppose let's say this is A and let's say this is D. Okay, so it is given that ABC is also a triangle, ABC is a triangle, so it is an isosceles triangle, so we can write this side is equal to this side. This is clear. And DBC is also another isosceles triangle in which this side is equal to this side, DB is equal to BC. Okay, and both the triangles have same base BC. ABC triangle lies on BC base and DBC triangle lies on the same base BC. It is clear now. So what is given in triangle ABC? What is given? AB is equal to AC, since it is an isosceles triangle. Okay, and according to the theorem number 7.2, we know if in an isosceles triangle any two sides are equal, then their opposite angles must be equal. So this angle must be equal to this angle. Okay, according to theorem 7.2. So you can write that ABC angle is equal to ACB angle. Clear? Next, it is also given that DBC is an isosceles triangle. In triangle DBC, DB is equal to BC. Right? Here you have to write the reason, that theorem 7.2. So in the triangle DBC also, this side DB is equal to this side DC. And according to theorem 7.2, if any two sides of an isosceles triangle are equal, then their opposite angles, the opposite angle of this side, this is the opposite angle, is equal to the opposite angle of another side. It means this angle must be equal to this angle. And for this triangle, this angle must be equal to this angle. Okay? So we have to write this, that DBC is equal to DCB by theorem 7.2. Every bit need to be written. Okay. Now what do we prove? We will prove that ABD angle, which angle? ABD angle is equal to ACD angle. ACD angle. Okay, we have to prove that ABD angle is equal to ACD angle. And another thing, I think I have missed to write that the triangle ABD is congruent to the triangle ACD. I have forgotten to write. Okay, so two things we need to prove here. To prove, first thing we have to prove that ABD angle is equal to ACD angle. Okay, and the second thing that we need to prove is triangle ABD is equal to the triangle, is congruent to the triangle ACD. Okay, so I have forgotten to write this thing. Okay, you can write it now. Now let's prove for the first statement. Okay, since we have proved or we have verified that this angle is equal to this angle. Yes or no? Yes. Suppose it is our equation number 1 and this is our equation number 2. Okay. So here we have to add equation 1 with equation 2. We have to add this equation with this equation. Whenever two equations are added, as I have told you, the left hand side must be added to the left hand side and the right hand side must be added to the right hand side. So let's add them. So in the left hand side we have to write the angle ABC plus angle DBC. These are the left hand side, and the right hand sides are ACB angle plus DCB angle. Did you understand? We have added the left hand side with left hand side, right hand side with the right hand side. Now let's see. We have had ABC. It means this angle. Plus DBC. That means this angle. See, we have added this angle with this angle. So what we will get? Whenever this small angle is added to this small angle, then we will get the total angle. Yes or no? Yes. These two are the parts of this large angle. So whenever this angle ABC is added with DBC, you will get the total angle to the large angle ABD. So in this place we can simply replace ABD angle because these two angles are added to give the large angle. Okay? Similarly, in the right hand side, what we have found? We have found angle ACB. This angle plus DCB. This small angle. So whenever this angle and this angles are added, we will get the total angle or not? Yes, because these are the part of this large angle. So this angle plus this angle is equal to total angle. Total angle means angle C or ACD. Understood? So what we have found? We have found that this angle ABD is equal to ACD. Understood? And we have found and proved the first statement that we need to prove. Angle ABD is equal to angle ACD. This is the proof for the statement 1. Clear? Moving to the second proof. So here, as you can see, we have to prove that the triangle ABD triangle. This is the point D. Okay. So in order to find the triangle, you have to join these two lines AD, so that we will get ABD triangle, and is congruent to the triangle ACD. So we have to prove that this triangle is congruent to this triangle. Okay. So let's prove. In order to prove this, we have to compare these two triangles. Okay. So between triangle ABD and triangle ACD. Okay, we will compare these two triangles. First thing is, as you can see, if we consider this triangle, ABD triangle, in this triangle, this side AB is equal to, in this triangle ACD triangles, this side AC. Why? Because it is given that ABC is an isosceles triangle and AB side is equal to AC side. It is given. So for the triangle ABD, we can write AB is equal to AC for the triangle ACD. This is clear. Next, since recently we have proved that this angle, ABD angle, is equal to this total angle. That means this is an angle for this triangle and this is also an angle for this triangle. So we can write B angle is equal to C, or ABD angle is equal to ACD angle. Okay. Third statement is that for the triangle ABD, this side means BD, and for the triangle SCD, this triangle, this side CD are also equal, since it is already given that BD is equal to CD. Why? Because BCD is also an isosceles triangle in which BD is equal to CD. So you can write it is given by proved. Okay, we have taken this by proving it. Now what we have identified here? We have identified that AB, this for this triangle ABD, this side and BD side and the angle. So this is the included angle. Similarly for this triangle ACD, this side and CD, this side and the included angle. So by SAS congruency, we can write that these two triangles must be congruent. Hence, we can write the triangle ABD is congruent to the triangle ACD by SAS congruency. Understood? Hence, it is proved. Understood? So, we have proved the true statement. The first statement is that we have to prove that ABD angle, that means this angle is equal to this angle, and the second statement is that this triangle is congruent to this triangle. Okay. So moving to the next question, question number 6. In question number 6, the statement is triangle ABC is an isosceles triangle. So let us draw the triangle ABC. So this is a triangle ABC. So moving to the next question, that is question number 6. In question number 6, it is given that triangle ABC is an isosceles triangle. So let us first draw an isosceles triangle. Suppose this is an isosceles triangle, and in this triangle ABC, AB is equal to AC. It is given. So AB is equal to, understood? Side BA is produced to D. Side BA, which side? The side BA is produced. Okay. So it is extended. Produced means it is extended in this direction. In this direction, like this. To a point D. It is given to a point D, such that AD is equal to AB. It means the length of AB must be equal to the length of AD. Understood? Now, what to prove? We have to prove that the angle BCD, which angle? BCD. It means we have to join this. Okay, we have to prove that BCD angle, the total angle BCD, this angle, is right angle. Means we have to prove that this BCD angle BCD is 90 degree. We have to prove this. Understood? So let us write what is given. It is given AP is equal to SC. Since it is given that ABC is an isosceles triangle, and in this triangle this side is equal to this side. And according to the theorem 7.2, we know if any two sides of an isosceles triangle are equal, then their opposite angles must be equal. This is the opposite angle of this side, and this is the opposite angle of this side. I am talking about which angle? This angle and this angle. So these two angles must be equal. So you can write the angle ABC. Angle ABC is equal to this angle ACB. Okay. If we can take this angle to be x, suppose this angle is x, then what is the value of this angle? It will be x. Clear? Next, it is given that in ADC triangle, this side is equal to this side. If we consider ADC as a triangle, then this side is equal to this side. It means it is also an isosceles triangle. And here AD is equal to AC. So we can write that the opposite angle of this side, that means this angle, is equal to opposite angle of this side, that means this angle. So this angle and this angle are also equal. So ADC is equal to ACD. This is clear. If we take this angle to be y, then what is the value of this angle? It is also y. Clear? Now, what we have to prove? To prove, we have to prove that this angle BCD is right angle. BCD. BCD is right angle. Right angle means it will be 90 degree. We have to prove this. So let's prove. How we can prove it? For this, we have to consider ABC triangle. In triangle ABC, we know that the sum of all the angle is equal to 180 degree. So this angle plus this angle plus this angle is equal to 180 degree. This angle means BAC. So BAC plus this angle means X plus X is equal to 180 degree. Clear? Implies BAC plus X plus X are 2X is equal to 180 degree. Implies BAC is equal to 180 degree minus 2X. We found it. We found the value of BAC. 2X moving to the right hand side, it will be negative. So BAC is equal to 180 degree minus 2X. Suppose this is equation 1. Clear? Now, Now we will consider another triangle, triangle ADC. In triangle ADC, this angle plus this angle plus this angle is also 180 degree. So we can write CAD plus this angle plus another angle is equal to 180 degree. We know it. So CAD plus 2y is equal to 180 degree. Clear? Implies angle CAD is equal to 180 degree minus 2y. This is the second conclusion that we get. Equation 2. Understood? Now what we will do? Now we will add this to equation. Let us add them. Okay, we will add this to equation. Adding equation 1 plus equation 2. So let us add them. Whenever we will add, the left hand side must be added with left hand side and right hand side must be added with right hand side. So we will get BSC plus left hand side is CAD is equal to the right hand side is 180 degree minus 2x plus again 180 degree minus 2y. Are you getting my point? See, in the left hand side what we will get? We will get BAC, that means this angle, plus CAD, that means this angle. So this angle and this angle, whenever these two angles are added, then what we will get? We will get 180 degree. Why? Because if we consider this as a straight line and this ray stands on it, this is a straight line, this ray stands on it, and these two angles are linear pair angles. That is why this angle plus this angle must be 180. So 180 degree. In this place we can write 180 degree is equal to 180 degree minus 2x plus 180 degree minus 12. Understood? You can write the reason here. Since there is no space, that's why I didn't write. But you can write that this angle and this angle are alternate interior. Now 180 degree. This 180 degree comes to the left hand side. This 180 degree comes to the left hand side. So in the right hand side we have minus 2x minus 2y. Clearly look at the calculation part. This 180 degree moves to the left hand side, so minus 180. This 180 moves to the left hand side, so minus 180. Then minus 2x and minus 2y remaining in the right hand side. Now see, 180 degree and minus 180 degree has been cancelled out. So what is remaining? Minus 180 degree is equal to. Now we can take minus h common, 2x plus 2y. This is clear, na? Negative sign, cancel. So what we will get? We will write it fast. 2x plus 2y is equal to 180 degree. 2 is common, so x plus y is equal to 180 degree. Implies 2 is moving to the right hand side. So what we will get? 180 degree, 2 is divided is equal to 90. So finally what we will get? We will get x plus y is equal to 90 degree. Okay, x means what? X means what? X means this angle. Okay, which angle? ACB. So what we will write here? So in the place of x, what you can write? In the place of x, we can write angle ACB. Implies angle ACB. Similarly, in the place of y, what we can write? In the place of y, we can write angle ACD is equal to 90. Okay, so in the left hand side we have found ACB angle, this angle plus this angle. So this angle plus this angle, can you write this angle as the total angle? Because these are the part of the total angle. So this part plus this part is equal to total. Total means which angle? Angle C. Okay, angle C means BCD is equal to 90 degree. So what we have found? We have found the angle BCD, this angle is equal to 90 degree. And we have to prove also this statement. BCD angle is equal to 90 degree and we have proved it. Okay, so this is now proved. Understood? So coming to the next question of this exercise, that is question number 7. According to the question number 7, it is given ABC is a right angle triangle. So let us first draw a right angle triangle. Okay, suppose this is a right angle triangle. Okay, the name of the triangle is ABC. Now it is given that in which angle A is 90 degree. Since this one is 90 degree, this angle is 90 degree, so we have to name this vertex as A, then it is B, then it is C. Understood? And AB is equal to SC. AB, this distance is equal to SC, this distance. Clear? Then find angle B and angle C. We have to find this angle and this angle. How we can find it? Let's find. Since though it is a right angle triangle and its one angle is 90 degree, but already it is given that this side AB is equal to this side. Already it is given AB is equal to SC. It is given. Yes or no? Yes. And we know according to the theorem 7.2, if in a triangle any two sides are equal, then it is known as isosceles triangle. So definitely it is an isosceles triangle and its two sides are equal. Then according to theorem 7.2, their opposite angle must be equal. If we consider this side, then opposite angle of this side is this angle. If we consider this side SC, then opposite angle of this side is this angle. So if this side and this sides are equal, then this angle and this angle must be equal. So implies you can write that this angle means ACB is equal to ABC. Okay? Why? Due to theorem 7.2. Understood? Now we have to find what? We have to find the angle B and angle C. Now this ACB is also known as angle C and ABC is also known as angle B. So we have to find angle C and angle B. Let us find it. Suppose we take this angle HX. Then what is the value of this angle? It is also X, because these two angles are equal. So we have taken C as X. Then what is the value of B? That is also X. So C is equal to B is equal to X. Clear? Now, as we know, in a triangle ABC, the sum of three angles is how much? 180 degree. So we can write angle A plus angle B plus angle C is equal to 180 degree. So A angle is 90 degree, B angle is X, C angle is X. X plus X are 2X, then this 90 is moved to the right hand side. It will be 180 minus 90, that is 90 degree. So we get 2x is equal to 90 degree, implies x is equal to 90 degree by 2, that is 45 degree. So we find the value of x to be 45 degree, and we have taken B, angle B as x, which is also 45 degree, angle C as x, which is also 45 degree. Hence we have found that both the angles value will become 45 and 45. Understood? If you want to verify, then it is very easy to verify. 45 plus 45 is 90, 90 plus 90 is 180. So all the angles are added to give 180 degree. Okay. And finally coming to the last question of this exercise, that is question number 8. In the question number 8, it gives you that so that the angles of an equilateral triangle is 60 degree. Okay. So we have to first draw an equilateral triangle. So what is an equilateral triangle? What is an equilateral triangle? A triangle in which all the three sides are equal is known as equilateral triangle. So if it is a equilateral triangle, then this side AB is equal to this side BC is equal to this side AC. Then it is known as an equilateral triangle. And we also know that in an equilateral triangle, each angle is how much? It is 60 degree. We know it. Okay. But today in this lecture, we will prove it. We will prove how the angle of an equilateral triangle is individually 60 degree. Okay. We shall prove it. So let's prove how it is done. Right. So let's prove. Since ABC is an equilateral triangle, ABC is an equilateral triangle. You also know it that in an equilateral triangle all the angles 60 degree. You know it. Okay. So this is an equilateral triangle in which AB is equal to BC is equal to AC or CA. This is clear. Now we have to prove all the angle individually will be 60. How? See, if we consider this side and this side, AB side and BC side, only AB and BC, forget about what is the length of AC. Okay, according to theorem 7.2, we know the angle opposite to the equal sides are equal. Angles opposite to the equal sides are equal. Since this side and this sides are equal, then what is the opposite angle of this side? This angle. Yes or no? Yes. And what is the opposite angle of this side? This angle. Since this side and this sides are equal, then can we write this angle and this angle are equal? Yes, we can write. Understood? So, if we take this angle is x, and what is the value of this angle? It is also x. Are you clear? Okay. Similarly, if we consider this side and this side, since this side and this sides are equal, we know according to theorem 7.2, if two sides are equal, then the opposite angle must be equal. So what is the opposite angle of this side? This one. What is the opposite angle of this side? This one. So this angle must be equal to this angle. Since we have taken that this angle is x, then what is the value of this angle? Also x. So literally, it concluded that if all the sides of a triangle are equal, then their angles also equal. Okay, since here all the three sides are equal, then we can write all three angles are also equal. So angle A is equal to angle B is equal to angle C by theorem 7.2. Understood? Now, in triangle ABC, all the three angles are added to give how much? A plus B plus C is how much? Is 180 degree. This is clear? We have taken A as x. Here you have to write, suppose angle A is equal to angle B is equal to angle C is equal to x. Okay, then in this place we can substitute x, in this place we can substitute x, and in this place also we can substitute x. We have assumed it is equal to 180 degree. Then x plus x is 3x is equal to 180 degree. X is 180 degree by 3, that is 60 degree. So we have found the value of x to be 60 degree. And now we can write that angle A is how much? We have taken angle A as x, which is also 60 degree. So this is 60. We have taken B as x, so B is also 60 degree. Finally, we have taken C as x, so C is also 60 degree. So what we have concluded? We have concluded in an equilateral triangle, if all the sides are equal, then all the angles must be equal and the value of each angle will become 60 degree. Okay.